Hello everyone, welcome to my channel. In this video, we're going to solve this exponential equation 2 to the power of 3x minus 1 minus 2 to the power of 5 minus 3x equals 6. And we'll be looking for the real values of x. And so let's go ahead with our solution. Our first step is to simplify the terms of the left side of the equation. So here, the left term can be written as 2 to the power of 3x times 2 to the power of negative 1. And then the second term, minus 2 to the power of 5 times 2 to the power of negative 3x equals 6. So this is from the exponent formula. If we have base a raised to exponent, let's say m plus n, this can be written the same way as a to the power of m times a to the power of n. Considering the left-hand side of the equation, if you notice, some of the exponents over here are negative 2 to the power of negative 1 and here 2 to the power of negative 3x. So we can put this down into the denominators, right? So taking into consideration the left-hand side of the equation, this is now written the same way as 2 to the power of 3x divided by 2 to the power of negative 1, going down to the denominator, it will be positive 1, or let's say just 2, simply 2 to positive 1. Then minus 2 to the fifth power divided by 2 to the negative 3x, here will become positive 3x. This is equal to 6. Simplifying our equation, getting rid of the denominators, that means we're multiplying the whole equation with 2 times 2 to the power of 3x. So we have 2 to the 3x times 2 to the 3x minus the second term becomes 2 times 2 to the fifth power equals 6 times 2, that is 12, times 2 to the 3x. Simplifying our equation and putting this variable all together to the left-hand side of the equation. So we have 2 to the power of 3x. This is the same written as 2 to the power of 3x, since it's multiplying this term by itself, so we can put it as a square right there, right? Then minus having this term to the left, so we have 12 times 2 to the 3x minus 2 times 2 to the fifth power. 2 to the fifth power is 32 times 2, that is 64. This is equal to 0. So now, if you notice, our equation turned into a quadratic equation. If you notice, because of the exponent 2 right there, and the base is 2 to the power of 3x. Likewise, on the second term, if we put parentheses on there, it becomes clear that 2 to the 3x can be substituted to a variable. So that will make this equation as a quadratic equation. So we're defining a new variable to represent 2 to the power of 3x into our equation. So we have here, let u be equal to 2 to the power of 3x, and substitute this value to our equation. So now we have u squared minus 12u minus 64 equals 0. And so from here, we can use the quadratic formula to find the value of u, or we can also use factoring to find the value of u, right? So we can use either quadratic formula or factoring, and so we use factoring. So we have here u and u, and what are the factors of negative 64? That when we add it up, it will turn up to be negative 12. And so the algebraic sum of the factors of negative 64 must be negative 12. So what are those factors of negative 64? So that will be 16 and 4, right? So it'll be 16 here and 4 here. And since the middle term is negative, so the bigger value assume the negative sign, and the smaller value assume the positive sign. Equating both factors to 0, we come up with u plus 4 equals 0. And taking u over here is equal to negative 4. And the other value of u minus 16 equals 0. U is equal to 16. And if we focus our attention on this value of u is negative 4, since u is a substituted variable in place of 2 to the power of 3x, and this value, 2 to the power of 3x, is positive, and yet the value of u over here is negative, so we're discarding this value of u, negative 4, since the value of 2 to the power of 3x must be a positive value, not negative value. So this value is rejected. So we're using value of u 16 in place of u over here to 2 to the power of 3x. Since we're looking for the real values of x, so we're taking this value of u, positive 16. And so we have here our equation. 2 to the power of 3x is equal to 16. And 16 can be expressed in base 2. That is 2 to the power of 4. So our equation now becomes 2 to the power of 3x equals 2 to the power of 4. We have the same base. That means we can equate their exponents. So that is 3x is equal to 4. Solving for x is equal to 4/3. That is our final answer. And so now let's check our answer. And so we have our original equation, 2 to the power of 3x minus 1 minus 2 to the power of 5 minus 3x equals 6. And we have here the value of x, 4/3. So substitute this value to this original equation that we have. So now we have 2 to the power of 3 times x is 4/3 minus 1 minus 2 to the power of 5 minus 3 times the value of x is 4/3. Is this equal to 6? So now simplify the exponent. So we have 2 to the power of 4/3 times 3, that's 4. Then minus 1, that is 3. Then minus 2 to the power, the exponent of the second term, 4/3 times 3 is 4. So that is 2 to the power of 5 minus 4, that's 1. This is equal to 6. 2 to the third power is 8. Minus 2 to the first power is 2. 8 minus 2 equals 6. So 6 is equal to 6. So this confirms that the value of x that we found is correct. That is, x is equal to 4/3 is our final answer. And so that's all for now. And if you are new to my channel, you might as well consider subscribing to my channel for more of this kind of videos, so you can have more practice solving exponential equations. Alright, thank you for watching. Have a great day everyone. I'll see you in the next one. Take care. Bye bye.